Welcome to this latest video in the playlist Introduction to Bioreactors. And in this particular video, I'm going to talk about what important considerations you have to make when you're looking at bioreactors for biodiesel production. Now let's just recap what biodiesel is. It's considered a renewable biofuel that's derived from biological sources. This can be vegetable oils or animal fats, and later on I will talk about the importance of the feedstock here. And actually this process, this transesterification process, as you can see below, which leads to the production of biodiesel, was already discovered in the 1850s by Patrick Duffy. This process involves an alcohol, which has a very specific side group, you notice is R star. This could be methanol, because that's the cheaper source, but you could also see higher order alcohols and some type of fatty acids. Now what then happens is you form an ester, and as you can see these R groups, the R group from the alcohol is moved over to the biodiesel. You also create quite a lot of side products, so this is glycerol. Before it was easy to sell glycerol, but actually you don't get a lot for it anymore, and that's why this process, you will see the choice of the feedstock, which can come with high costs, and the process costs that can hamper commercialization quite a bit, even though biodiesel is widespread. Another thing which you have to note here when you look at the reaction, you will see this is a reversible reaction. So this happens with temperature, but it is in equilibrium. So that also means that you will have to consider, for instance, the removal of the glycerol or a removal of the biodiesel itself in order to move it towards the right and to produce more of your product. So the selection of the feedstock is critical to this process because we say this is a renewable biofuel. So actually the source that you pick should be renewable. So for instance, you could think of, for instance, some side products or products that are waste products that are not actually used. But actually some of the biological sources to cultivate it come with very high carbon dioxide emissions. So not every biofuel is renewable. So it really depends on the source. However, in this video, as this is mainly about the bioreactor itself, I'm not going to go into detail, but please consider that it's very important to see where the biodiesel actually comes from. Let's have a look at the production of biodiesels and what operating modes you can consider for your bioreactor. So here I can see in this table, which comes from the source that's below, here I have a comparison between the typical operating modes that we use, which are batch, semi-batch and continuous. Continuous means that you have a continuous feed coming in and you continuously harvest the product going out. As the operating costs are relatively high, as mentioned in the previous slides, and also the product itself is not very high value, you will see that this prefers a continuous process. So this is because this is easier to produce on large scale and you can keep the cost very much down by doing this. So you would have also more uniform a product, unlike a batch where you can have more batch to batch variation. So some of the downside if you compare it to batch is that the versatility is lower and the scale up can be more complex. So these might be considerations that you take into account if you would go for a batch process. What we also should know that if we look at the previous reaction, this requires a catalyst. So this can be either an acid or a base. Base is more typical. You can have metal oxides, or you can make use of a supercritical process using supercritical carbon dioxide. But we'll come back to that later on. Now the problem here that if you make use of this catalyst, that it needs to be removed. And that can obviously lead to impurities in the system, but mainly it comes with higher costs. And more complex operations. Then if you would use supercritical conditions, you don't have to remove the catalyst, but if you're working on the more extreme conditions, that add to the cost. So there are quite a few different types of reactors that you can then use for biodiesel. The most simple one, and the one that's probably used the most, are fermenters. So fermenters, they convert sugars into other compounds using microorganisms. And the most common configuration, because of its ease of use, is a continuous stirred tank reactor. Usually would comprise a cylindrical tank that is equipped with a stirrer in order to promote the mixing, which you will see later on is very important for biodiesel production. And it can be, so depending on the microorganism that you're using, can be aerobic or you can work on the anaerobic conditions. So something which is less common but is definitely gaining traction from the community because of the use of sustainable sources such as algae are photobioreactors. So in that case, you use light as an energy source for the microorganisms rather than sugars. And as I mentioned, you can work with algae, but also certain cyanobacteria can be involved in this process. So typically you would have a closed system. However, you also have like open systems. For instance, you could have like a pond where you have natural light coming in. What you would typically see is that a tubular closed system, and this tubular system really enhances the production rate and is much easier to scale up. So finally, what you can also use for production of biofuels, not necessarily so much biodiesel, and not so common, is the use of electrobioreactors. And there, rather than light or sugars, you use electricity as a source for the microorganisms to produce compounds. And typical microorganisms are Geobacter and Shigella that are used in this. So things are, for instance, a microbial fuel cell system. They can produce electricity, but they can also be employed for the production of certain compounds. Now, depending on the type of reactor you're using, there are different parameters that are important. However, in general, I will talk about what are the most important things to consider for your bioreactor. Now, the first thing and the most obvious thing is your catalyst. So if you're not using a supercritical process, there is a maximum concentration of catalyst that you can use. So it will kind of peak and then it will go down. So you will need to find the optimal concentration of catalysts. And obviously you want to keep this as low as possible in order to produce the most product. But you will also see that if you go above that critical point, actually your concentration or the amount of product that you'll make will actually go down. So you need to optimize the concentration, but this very much depends on the type of catalyst, but also on the size and the shape. So we know, for instance, that catalysts that are smaller, they have a higher surface area, which will enhance your production overall. But what's also important to consider is how you're going to remove that catalyst afterwards and the cost of it. So if you remember the reaction, it's a reversible reaction. So it's very important the ratio between the methanol or the alcohol that you're using versus the biodiesel that you're producing. And actually this alcohol determines the yield. So you need to optimize this concentration, or you need to think about removal of products at the end. So you push the reaction towards the right in order to increase your yield. Then the mass transfer and the mixing in the system is very complex because you're working mostly with a two-phase system. So we have an immiscible alcohol oil phase, and that's why it's very difficult for these two compounds to react. So we need to make sure that the mixing is very much enhanced in order for the reaction to complete at a faster rate. So obviously, if you use a stirrer at a very high rate, that might be very good for your mixing, but first of all, it can have an impact on the microorganisms that you're using, but it can also reduce the economic viability. The fourth point relates to the residence time, and in the next slide, I'll actually go into a little bit more detail on this. If we're working in a continuous system, it's not the same as in a batch system. So in a batch system, you would have one specific residence time, you stop your reaction, and you go on to the next batch. However, if we work in a continuous system, there's a residence time distribution, which is continuously going on as long as your reaction is running. Now, things to consider here, even though it's continuous, your reaction can't go on forever. So for instance, you might get poisoning of your catalyst, where your catalyst stops working, you might have other impurities. So they do have like a finite lifetime. So you need to have a think about when you actually stop your reaction. So when do you still get the most yield out and the most per product. And also you need to optimize the residence depending on the biological source and the operation conditions that you're working with. So more you will see in the next table. And then the final point here, which is very obvious, whatever feedstock you are working with will have different conditions that you're working with. So you can't just apply one reactor and then use different feedstock. So it needs to be really optimized towards the system that you're working with. And I think this table nicely exemplifies why it's so important that you consider the feedstock that you're working with, but also the residence time and the temperature are very important. Now, generally, we'll see that the reaction needs to be at least 32 degrees Celsius. However, we can see that the oil source that you're using really has a very different temperature that we're working with and a different alcohol to oil molar ratio. Now, all of them have relatively high yield, so compared to a lot of reactions, you will see biodiesel typically has a yield of over 90%, but the reaction time can vary from as little as 30 minutes at 32 degrees to like 150 minutes for canola at 60 degrees. Obviously, the higher the temperature needs to be, the more power needs to go into your system, so the more expensive it becomes. So actually the way how you heat your system and what kind of cooling that you need to use are very important. So typical systems could be, for instance, a jacket that you have outside of the reactor, but because of these high operating costs, people are looking at alternatives. So I have another video on which looks at heat transfer in bioreactors. But things that people have been looking at include, for instance, the use of a microwave, which can also be very good at avoiding hotspots that you might get in your reactor. But the use of radio frequency seems to be the most economically viable. So there are like different methods of how you can actually heat your reactor and how you can cool your reactor, and all of these things are very important when it comes to the cost. So these are crucial considerations to make when you're designing your system. We've looked at some general parameters, but it's very important to consider the intensification of the process. Now, we can obviously enhance the reaction by, for instance, going to higher pressures or higher temperatures, as we will have seen, but this will come at like an economic cost. So this is like a balance that has to be considered. Now, what people are also doing, and one of the things that I mentioned, the fact that you're working with an immiscible phase, that makes the reaction complicated. So what you could do is you could add co-solvents to create a one-phase system, which will really increase your mixing and thus will improve the overall yield and the production. Now, this can be done using supercritical carbon dioxide, but people are also looking at more renewable and designer solvents, because particularly this process is supposed to be generating a renewable feedstock. There are also catalysts which are very specific towards this type of system. So you have phase transfer catalysts, it can work in both phases. And people will also consider easier ways of removal of your catalyst towards the end, even though that is more towards the downstream process. So the downstream processing is also very important for the production cost, but because I have like a separate playlist on this matter, you can have a look at another video to see how we would consider this for the production of biodiesel. Thanks for watching, and hopefully after seeing this video you'll have an idea of important considerations to make when it comes to designing your bioreactor for biodiesel. So have a look at the link that I've provided, because this is a review paper, a lot of the points that are made and things to consider. For more information on the topic, do have a look at our playlist, An Introduction to Bioreactors.